What was happening during the Hadean time? The Hadean time. This is the very early time of Earth's history. It happened about 4.6 to 3.8 billion years ago. Solar system formation. Picture a big spinning cloud of gas and dust around the young sun. This cloud is called an accretion disk. The sun and the planets, including Earth, formed from this cloud. 2. What is the Hadean eon? Think of an eon as a super long time. The Hadean eon is like the first chapter of Earth's history. It's the time before there were any solid rocks on Earth. Oldest zircons. Zircons are tiny crystals. The oldest ones we found are about 4.4 billion years old. These are some of the first pieces of solid Earth we know about. 3. Late heavy bombardment. Late heavy bombardment. This was a rough time when many big space rocks, asteroids, crashed into the planets, including Earth. This happened between 4.1 and 3.8 billion years ago. Impact craters. When these space rocks hit the planets, they made big holes called craters. The moon has lots of these craters, and Earth, Mercury, Venus, and Mars have them too. Let's break down the Archean eon step by step in simple terms. 1. What happened during the Archean eon? Time period. The Archean eon lasted from about 3.8 to 2.5 billion years ago. Earth's crust formation. During this time, Earth's surface cooled down enough to start forming solid rocks and big land areas called continental plates. 2. Tectonic activity. Different tectonic style. Early Earth might have had more intense tectonic activity. Imagine Earth's crust as a giant puzzle that was constantly shifting and moving more vigorously than today. This movement helped form and recycle the crust. Plate tectonics. Plates are huge pieces of Earth's crust. During the Archean, these plates moved around a lot, causing a lot of recycling of rocks and land. 3. Cratonization and continent formation. Cratonization. Cratons are the old, stable parts of the continental crust. Some scientists think that early Earth was too hot for these to form. This is because the Earth's mantle, the layer beneath the crust, was hotter and moving more quickly. Cooling down. As Earth cooled over time, the mantle's movement slowed, which allowed cratons and bigger continents to form. 4. Types of rocks. Archean rocks. Rocks from this time are often very changed, metamorphosed, and come from deep-sea environments. Examples include gray wax, sandstone-like rocks; mudstones, fine-grained rocks made from mud; banded iron formations, layers of iron-rich rocks; greenstone belts. These are special rock formations from the Archean. They have high-grade rocks. These come from volcanic islands. Low-grade rocks. These come from sediments eroded from the islands and deposited in the ocean. 5. Earth's magnetic field. Magnetic field formation. By around 3.5 billion years ago, Earth developed a magnetic field. This magnetic field is like a shield that protects the planet. Solar wind. The sun was much stronger back then, so the magnetic field was crucial. It helped keep Earth's atmosphere from being blown away by solar wind, which likely happened to Mars. Magnetosphere. This is the area around Earth protected by the magnetic field. It was smaller and weaker compared to today's Let's break down the Proterozoic eon step by step in simple terms. 1. Time period. Proterozoic eon. This lasted from about 2.5 billion years ago, 2,500 ma, to 570 million years ago, 570 ma. 2. Geologic record. Let's break down the Proterozoic eon step by step in simple terms. 1. Time period. Proterozoic eon. This lasted from about 2.5 billion years ago, 2,500 ma, to 570 million years ago, 570 ma. 2. Geologic record. Better record. Unlike the Archean eon, we have more and clearer information about the Proterozoic. The rocks from this time are easier to study. Shallow seas. During the Proterozoic, much of the Earth's surface was covered by shallow seas, not just deep oceans like in the Archean. This means we have many layers of sedimentary rocks from these shallow seas. Less metamorphosed rocks. The rocks from the Proterozoic are less changed compared to those from the Archean. Many are still in their original form. 3. Continental formation. Continental accretion. This is when new landmasses or continents are added. During the Proterozoic, this happened rapidly and on a large scale. Supercontinent cycles, large landmasses, called supercontinents, formed and broke apart during this eon. These cycles of formation and breakup are a major feature of the Proterozoic. Orogenic activity. This refers to the formation of mountain ranges. The Proterozoic saw mountain-building activities similar to what we see today. Number 4. Glaciations. First glaciations. The Proterozoic is when we first see evidence of glaciers, ice sheets, form. The Phanerozoic eon. What is it? The Phanerozoic eon is a huge block of Earth's history that started around 545 million years ago and continues to today. What happened? Continents moved. At first, the continents were spread out. Over time, they came together to form a giant landmass called Pangaea. Later, Pangaea broke apart into the continents we have now. 3 big time periods. The Phanerozoic eon is divided into 3 main periods called eras. 1. Paleozoic era. 2. Mesozoic era. 3. Cenozoic era. The Paleozoic era time frame, about 542 million years ago to 251 million years ago. What happened? Breaking up and coming together. At the start, the continents were small and separated. By the end of this era, they came together to form a supercontinent called Pangaea. 6 important periods. 1. Cambrian. 2. Ordovician. 3. Silurian. 4. Devonian. 5. Carboniferous. 6. Permian. Cambrian period. Time frame, about 542 million years ago. What happened? Continents. Continents were breaking apart from an old supercontinent. Oceans. The oceans were shallow and covered much of the Earth. Continental drift. The continents moved around a lot, with some drifting towards the poles. Example, imagine the Earth like a jigsaw puzzle, where the pieces, continents, are moving around and changing their spots. Ordovician period. Time frame, about 488 million years ago. What happened? Continents. The southern continents came together to form Gondwana, which then drifted towards the South Pole. Extinction. A big ice age caused many sea creatures to die off. Continental drift. Some continents moved closer to each other. Example. Picture Gondwana like a giant ice cube slowly moving over the South Pole. Silurian period. Time frame. About 443 million years ago. What happened? Continents. Gondwana continued moving south, but the ice caps were smaller than before. New land. Small land masses started coming together near the equator to form a new supercontinent called Euramerica. Example, think of small land pieces like Lego blocks coming together to build a new shape. Devonian period. Time frame, about 416 to 359 million years ago. What happened? Tectonic activity. Continents like Laurentia and Baltica collided to form a new landmass called Euramerica. Sea levels. The seas were high, covering much of the land. Example, imagine continents as giant puzzle pieces crashing into each other to form new shapes. Carboniferous period, time frame, about 359 to 299 million years ago. What happened? Glaciation. Gondwana was covered in ice, but the tropics stayed warm. Mountain building. Continents came together, creating mountain ranges. Example, picture a huge landmass with ice at the poles and lush green swamps near the equator. Permian period. Time frame, about 299 to 251 million years ago. What happened? Supercontinent. All major landmasses, except parts of East Asia, joined to form Pangaea. Climate. Pangaea created extreme climates, with hot deserts and cold regions. Example, imagine a giant landmass stretching from the equator to the poles, causing very different climates across the planet. Extra information. Pangaea, a giant supercontinent that eventually split into today's continents. Panthalassa, the large ocean surrounding Pangaea. Tethys Ocean, a significant ocean that started forming in the Permian and played a big role in the Mesozoic era. Overview shows how the continents and oceans changed over millions of years, creating the world we live in today. The Mesozoic era. What is the Mesozoic era? The Mesozoic era is a long period of time from about 251 million years ago, Ma, to 65 Ma. It is divided into 3 main periods, the Triassic, Jurassic, and Cretaceous. What happened during this era? Pangaea split. At the start, there was one big landmass called Pangaea. Over time, it broke into 2 big pieces. Laurasia in the north, Gondwana in the south. Ocean formation. This splitting created new oceans, like the Atlantic Ocean. Triassic period. about 251 to 199.6 May. What was happening? Pangaea. All the land was joined in one big supercontinent called Pangaea. Imagine a giant landmass like a big cookie. Oceans. Tethys Sea, a big sea to the east of Pangaea. Panthalassa, a huge ocean surrounding Pangaea. Breaking apart. Pangaea began to crack, but it didn't split completely yet. Example, rift formation, like cracking a giant cookie into pieces. The area where Pangaea started breaking up left sediments we now call the Newark supergroup. Marine life. Few marine deposits. Because most of the land was one big mass, there weren't many marine deposits, layers of rocks from oceans, except in a few places like Western Europe. Jurassic period, about 199.6 to 145.4 May. What was happening? Continent splitting. Pangaea continued to break apart. Laurasia, north, and Gondwana, south, were forming. The Gulf of Mexico opened up between North America and Mexico. Sea changes. The Tethys Sea closed and new seas formed. Climate. Warm and no ice caps near the poles. Example, Jurassic coast. In Western Europe, there were shallow tropical seas, and you can visit the Jurassic coast in England to see rocks from this time. North America, marine deposits, limited, mostly in the western parts. The Morrison Formation had land deposits like old riverbeds. Cretaceous period, about 145.5 to 65 May. What was happening? Final breakup. Pangaea completed its breakup into the continents we have today. Gondwana split. South America, Antarctica, and Australia moved away from Africa, creating the South Atlantic and Indian Oceans. Sea levels. The seas covered much of the land, with big shallow seas over parts of North America and Europe. Example, chalk formation. Lots of chalk formed during this time, more than in any other period. Chalk is made from tiny sea creatures' shells. Famous rocks. In North America, places like the Smoky Hill Chalk in Kansas and the Hell Creek Formation have lots of fossils. Special features. Deccan traps. Massive lava flows in what is now India, formed late in the Cretaceous and into the early Paleocene. Summary. Triassic period. Pangaea started breaking apart, forming new seas, but marine deposits were limited. Jurassic period. The continents continued to split, with warm climates and lots of shallow seas. Cretaceous period. Continents reached their current positions, with high sea levels and lots of chalk formation. Sure. Let's break down the Cenozoic era into simple terms. Cenozoic era overview. The Cenozoic era started about 65.5 million years ago, right after the dinosaurs went extinct. It's still happening today. Big changes in the Cenozoic era. 1. Continents moved. By the end of the Mesozoic era, the continents were already starting to look like they do today. Laurasia split into North America and Eurasia. Gondwana split into South America, Africa, Australia, Antarctica, and the Indian subcontinent. India crashed into Asia, making the Himalayas. The Tethys Sea closed up, forming the Mediterranean Sea. Paleogene period, 65.5 to 23 million years ago. This period is divided into three parts: Paleocene, Eocene, and Oligocene. Paleocene epoch, 65.5 to 55.8 million years ago. Continents drifting. The continents were moving towards their current positions. Laurasia was still together, and Europe was joined to Greenland. North America and Asia had a land bridge. Mountain building. The Rocky Mountains in North America were still forming. Tethys Ocean closing. Africa was moving towards Europe, closing the Tethys Ocean. India was moving towards Asia, starting to form the Himalayas. Eocene epoch, 55.8 to 33.9 million years ago. Australia and Antarctica split. When Australia split from Antarctica, warm ocean currents changed direction, making Antarctica colder and starting to form ice. Mountain building. The Alps started forming in Europe, and mountain building continued in North America. The Tethys Sea disappeared, and the Mediterranean was left. India and Asia. India was moving into Asia, making the Himalayas. Oligocene epoch, 34 to 23 million years ago. Ice caps forming. Antarctica developed a permanent ice cap. Mountain building continued. The Alps were rising, and South America was moving towards North America. There was still a land bridge between North America and Europe, and South America finally detached from Antarctica. Neogene period, 23 to 2.588 million years ago. This period includes the Miocene, Pliocene, Pleistocene, and Holocene epochs. Miocene epoch, 23 to 5.332 million years ago. Continents almost in place. Continents were close to their current positions. South America and North America were still separate. Andes Mountains. The Andes Mountains rose in South America, and India continued to push into Asia. Mediterranean Sea changes. The Mediterranean Sea nearly dried up during a period known as the Messinian salinity crisis. Pliocene epoch, 5.332 to 2.588 million years ago. Land bridge. South America joined North America via the Isthmus of Panama. This changed the climate, cooling the Atlantic Ocean. Ice Age begins. Near the end of the Pliocene, the Ice Age started and the first large ice sheets formed. Megalayan Age, a simple overview. What is the Megalayan Age? Newest subdivision. The Megalayan Age is the most recent part of the Holocene epoch. Started about 4,200 years ago, it began during a major drought and cooling period. Why is it important? Drought impact. The start of the Megalayan Age is marked by a severe drought that lasted for about 200 years. Global effects. This drought disrupted many ancient civilizations, like those in Egypt, Greece, Syria, Mesopotamia, the Indus Valley, and the Yangtze River Valley. Why is it called Megalayan? Naming. The Megalayan Age is named after the Mamla caves in Meghalaya, India, where key geological evidence was found. Evidence. Unlike earlier ages, which were studied using ice cores from Greenland, the Megalayan Age was defined using stalagmites, cave formations in India. These stalagmites helped scientists understand the climate during this period. Key points. Holocene epoch subdivisions. The Holocene epoch is divided into 3 ages. 1. Greenlandian Age. 2. North Grippian Age. 3. Megalayan Age. Research methods. For older periods, scientists used ice cores from Greenland. For the Megalayan Age, they used stalagmites from caves in India to study climate records. Summary. The Megalayan Age is the latest division of the Holocene epoch, starting around 4,200 years ago, marked by a severe drought affecting many ancient civilizations. Its name comes from evidence found in India's Mamla caves, and it was defined using stalagmite records rather than ice cores.